Today about graphing lines and solving equations using substitution elimination. We're going to talk about linear equations. Tomorrow we're going to talk about something that's called nonlinear, which means the exponent is going to be 2. But we're going to solve it the exact same way, so it's nothing you guys can't handle. Question? We don't need a calculator for this, do we? Or is it... I don't know if we're going to let you use calculators or not, so go ahead and do it without, and then we'll kind of see. But there's 3 ways that you can solve an equation. You can solve by graphing, you can solve by elimination, and substitution. So we're going to show all different ways. Guys, when you have when you have an answer, when you're solving a system, you write your answer in an ordered pair. You have an x value and a y value. You can always check your answers. That's what's so great about this. You can always check your answers because whatever you get for x and y, you can just plug them into the original and check your answer. If you're graphing, where the lines intersect, where they touch, is their solution. If they don't intersect, they're 2 parallel lines that don't intersect, your answer is no solution. If it's the same line on top of itself, your answer is infinite solutions. We'll talk about that a little more. But it says, what is the solution to the following systems of equation? All right, a lot of times you're able to just pick whatever you want to do. Substitution, elimination, and graphing. If we were going to graph this, in either one of these, if we were going to graph this, in the first equation, what is your slope? 3 over 2. And what's the y-intercept? -2. So you'd put a point at -2, go up 3 over 2, up 3 over 2, right? Draw your line. The second one, where's your y-intercept? 3. What's your slope? -1. You would go down 1 over 1, down 1 over 1, and graph it, right? Wherever they touch, that's the solution. In this case, I'm going to use substitution. The reason I'm going to use substitution, when you substitute, you put one in for the other. Do you guys notice how this both says y equals? So I could replace one of the y's with one of the other equations. Do you guys agree with me that these 2 equations equal each other? Yes. -x plus 3 equals 3 over 2x minus 2. How do you solve a basic equation when there's numbers on either side and letters on either side? What do we have to do? You got to get both x's on one side and both numbers on one side. So I'm going to add x over here and add x over here. Whoops. And then I'm going to add 2 and add 2. So my x's over here cancel out, right? What's 3 plus 2? 5. Now, this is not hard, guys. I have 1x, correct? How can I write 1x as a fraction? Perfect. This is 2 over 2x, right? So what's 3 over 2 plus 2 over 2? 5 over 2x, and then these cancel out. How do you get x all by itself? You can divide, or you're actually going to multiply by what? The reciprocal. I can multiply this side by 2 over 5, and then this side by 2 over 5. So what do I do here? This cancels. I get x equals 10 over 5, which is 2. Now, once I know what x equals, how do I figure out what y equals? You plug it in. You can plug it into whichever equation you want. It doesn't matter. You get the same answer. Which one do you guys want to plug it into? The bottom one, because you're like, oh, there's no fractions. Guys, if you notice, the 2's would cancel out, but no big deal. So if you're going to find y, you'd say y equals, well, I have negative, my x value is 2, plus 3. So y equals, what's -2 plus 3? 1. And the way that we write our answer is an ordered pair. So it'd be 2, 1. And what you can do with that, which I am not going to make you do, but I think is a really good idea, is you can take this x and y coordinate that you found, plug it into the originals, and just make sure that they satisfy the equation. Then that means that's your solution. Question. All right, now guys, again, you're going to be given the directions sometimes to solve a certain way, and then you're also going to be given the option to do what you want. This says solve using substitution. What does substitute mean? You replace with something, right? Do you guys see how this second equation says y equals? So we can take this right here and plug it in for that y value, right? I could say x plus 2. Well, instead of y, I'm going to write negative 3x minus 8, and then finish the problem, equals negative 1. Now, can we solve this? Ooh, bad color choice, guys, sorry. Can we solve this?
Yeah.
What do we do first?
You get the x and all one.
Well, hold on. What do we have to do first?
Oh, distribute.
We got to distribute. You got to distribute, combine like terms, all that stuff. So x plus, actually, it's not. X minus 6x, right? Minus 16 equals negative 1. Can I combine anything on the left-hand side? X and negative 6x is negative 5x. Minus 16 equals negative 1. Now what?
Add 16.
Add 16 to both sides. Perfect. So negative 5x equals 15. Divide by negative 5. And x equals? X equals negative 3. Good. Very good. So now that we know what x equals, how do we figure out what y equals? Plug it back in. I'm going to plug it into what?
Y.
The second one? That's fine. It doesn't matter. You can do either one. So y equals, I have negative 3 times negative 3, excuse me, minus 8. What's negative 3 times negative 3? 9. And 9 minus 8 is?
1.
So y equals 1. How do I want the answer written? Which would be? Negative 3, comma 1. Perfect. Now, we might get a few, and I'll go over some examples that have decimals, that have fractions. I'll show you how to either multiply by a number or divide through something to where you get a nice, easy equation to just set up and solve. All right, this question says the lines of these two equations. We've done one. We talked about graphing. Is this set up so it's easy to graph? No. Graphing needs to be set up in what? Y equals mx plus b. Could we move everything over to one side and get it to y equals mx plus b? Sure. Is this set up nice and easy for a substitution? Do you have just y equals something or x equals something where you just plug it in?
No.
No. Generally, elimination is what we like to do the most. And elimination means exactly what it says. You eliminate a variable. So let's look at the two variables we have. We have x's and y's. When you use elimination, you want to get the variables coefficients, that's the numbers in front, to be exact opposites. It doesn't matter which one you eliminate. You can eliminate x's, you can eliminate y's. I always go for the thing that's easier. Yeah. Okay, why is y easier?
Because you just multiply by 2.
If I multiply this whole top equation by 2, right, everything, so this becomes 8x, 2 times y becomes positive 2y, and then the other side of the equal sign, so 2 times 10 equals 20. Do you guys see now how your y variables can cancel out because you have a positive 2y and a negative 2y, right? So now we combine them. What's 3 plus 8?
11.
So I have 11x, this cancels out, equals, what's 20 plus 13? 33. Now what do I do? Divide by 11, and x equals 3. Now how do I figure out what y is? Plug it into one of the originals. Doesn't matter which one. I'm going to do the top one because it's shorter.
You can't plug it into the 8x one?
Yeah, you can.
Oh.
But it's just more work. I'm going to plug it into the top. 4 times 3 plus y equals 10. So 12 plus y equals 10, right? Minus 12 minus 12. Y equals what?
-2.
So how do I write my answer? 3 comma negative 2. Is there a big difference if I put negative 2 comma 3? Yeah. So make sure you guys write it as an ordered pair, x comma y. And how do I know for sure, before I even go on to the next one, how do I know that, I already know that I'm right? You just plug it back in. God bless you. You just plug it back in. Good job. All right, let's do a graphing one. And notice, guys, I color-coded this for you. But again, some of them might ask you on your test, solve by substitution elimination. Some might just say, hey, solve it. So do what you want on that one. But in case of graphing, remember when we graph, y equals mx plus b. Write that down. M is your slope. It's how much you go up and over, your rise over run. And b is your y-intercept. Another thing that you guys have to remember, a positive slope, the line goes upward. If you have a negative slope, it goes downwards. All right, that's important so you get your intersection correct.
What's the one where it's like flat? What's that like?
0. Up and down is undefined. Good. So here, I'm going to do 2 different colors. My slope here is 2 over 1, right? And my y-intercept is at positive 1. So I'm going to go to positive 1. And my slope is up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Right? You guys agree? I'm going to draw the straightest line I possibly can. Remember, there's arrowheads on the end of both of your lines. Arrows. So my second one is 3 over 2x plus 0. Why did I add that plus 0? I want you guys to know where your intercept is. If you don't see a number, you assume it's 0, but I'm just writing that so we see it. So here's my slope, and there's my y-intercept. So I'm going to start at 0. And from 0, I go up how many over how many?
Up 3 over 2.
Up 3, 1, 2, 3 over 2, 1, 2. Then I go up 3, 1, 2, 3 over 2, 1, 2. So down 3, 1, 2, 3 over 2.
Do we have to find where they intersect or just?
I want you to draw the line. Don't just draw I want to see both lines. Good question, because you were just counting and you could see where they cross. But I do want to see both lines drawn. And then the way that you would answer this question is you would tell me what that point is. Where do they intersect? What is that point?
-3, -2.
It's at negative, from here I go 1, 2, -2, -3. So it's at -2, -3. And then how do I know for sure that I'm right?
Plug it in.
All right, so when you're graphing, I want to see both lines, so good question. And then I want to know the intersection point. Don't just draw it. Don't just tell me right here. Actually write the ordered pair, and then you guys can plug it back in and check. All right, we good? All right, we're just going to do a bunch of these. How is this set up? How would you approach this problem? Is it set up to graph?
No.
Is it set up for substitution?
Yes.
Does it just say y equals? So we can just do it? Yeah, so let's do elimination. All right, I'm going to rewrite it out here so I have a little more room.
Well, that's the one I meant.
It's okay. 5x plus 4y equals 7. And then 2x minus 3y equals 3. Now, a lot of you will ask me, how do I know what I should do? First of all, if you want to always eliminate one variable, then just get that in your mind. I always want to do x. Or you can kind of look at it a little methodically, because if something is the exact opposite, one positive and one what? Negative. So look at the x's. They're both positive. That means if you were eliminating, you'd have to multiply one equation by a negative number and one by a positive. But since y's are already one positive, one negative, wouldn't it be easier to just figure out what you could multiply but to eliminate?
Yeah.
What do 4 and 3 both make?
12.
12, right? So what would I have to multiply the top equation by?
3.
And what would I multiply the bottom equation by?
4.
Perfect.
What happens if you did, or what if you made it 10? Like
You could do that. It would have to be a negative, either 5 or a negative 2.
It would just be harder to solve.
No, not at all. So guys, watch. Girls, stay with me, please. You have to distribute all the way through both sides of the equal sign. So 3 times 5 is 15. 3 times 4 is plus 12y. And then 3 times 7 is 21. And then on the bottom, I have 4 times 2 is 8. 4 times negative 3 is negative 12y. And then 4 times 3 is 12. Everybody with me? So now we combine down. What's 15 plus 8? 23. So 23x. What happens with a positive 12 and a negative 12? They cancel. And then what's 21
33.
plus 12? Equals what? 33. Okay. And then now what do I do?
Divide by 26.
Going to divide by 23. So I get x equals 33 over 23. Kind of gross? Yeah, but that's okay. You're allowed to get fractional answers. Sometimes they're prettier than others, but that's okay. Allie, did you do it the other way?
Yeah, I got y equals 1 over negative 23.
Okay, so let's go backwards here. Which one should we plug x into? Want to do the 2x?
Oh, yeah, so.
Okay, so we'll say 2 times 33 over 23, right? Minus 3y equals 3. So what's 2 times 33? What is it?
Wait, why did you do 2 times?
I plugged it into this equation.
Oh.
So 66 over 23, right? Minus 3y equals. I'm going to have to get a common denominator, correct? Because this is 3 over 1. So let's go ahead and just change that into 23. If I change this to 23, I multiply the bottom by 23, then I multiply the top. What's 23 times 3? 69. So 69 over 23, right? So I want to get y all by itself. So we're going to subtract 66 over 23 minus 66 over 23. So what's 69 minus 66? 3 equals 3 over 23, right? Now I want y by itself. Divide both sides by negative 3, which is the same as multiplying both sides by negative 1/3. So my 3's will cancel out, and what do we get? Y equals negative 1 over 23. Is that what you told me you got, Allie?
Yeah.
Perfect. So we write our answer as 33 over 23, comma, negative 1 over 23. No. You know why I would make you graph that? Because I don't want to grade your graphs. No. If it's not something fairly pretty, then you're not going to graph it. But you can get fractional answers. That's not, you guys, everybody in here can handle fractions. You may think you can't, but you can't. All right, let's look at number 6. Just upon investigation, what is this already easily set up to do? Y substitution. They both say x equals. So you can literally just write x equals one thing on the left and one thing on the right. So negative 4y plus 10 equals 2y minus 14. We want letters on one side, numbers on the other. So I'm going to subtract 2y from both sides. And then I'm going to subtract 10 from both sides. Everybody agree with me? I did 2 things in one step. Negative 4 and negative 2 gives me negative 6y. 10's cancel. 2's cancel. Negative 14 and negative 10 give me negative 24. Right? Divide by negative 6. And y equals 4. Now that I know that y equals 4, how do I find out what x equals? Plug it back in. I'm going to put it in the bottom one. X equals 2 times 4 minus 14. So 8 minus 14 equals negative 6. So I found out that my answer is negative 6 comma 4. Now if I want to be studious and say, hey, I'm wondering if I'm really right, what do? You plug it back in. Got to. All right, so the next one. Obviously, what do they want us to do on this one? They want us to graph. It says to graph. There's a graph. One equation is already set up pretty for us. I believe, yeah, that's just a regular 1/4. So my slope here is 1/4, right? And my y-intercept is negative 4. Everybody see that? So I'm going to go to negative 4. 1, 2. And then 1 over 4, up 1, 1, 2, 3, 4. Notice how I went up and right and then down and left because it's a positive line. Okay, here's my line. Now the next equation is not set up into y equals. Can we get it there?
Yeah.
Yes. What do I do first?
Add 2x.
We're going to subtract, agree, move that 2x, but we're going to subtract it. So it becomes negative 8y equals negative 2x plus 8. And then what?
Divide by negative 8.
Divide everything by negative 8. So I get y equals 1/4 x minus 2. Yeah?
1.
Oh, golly. Thank you. Honestly, I read that as a 4. Sorry. Thank you. All right, so here is my slope. And here's my y-intercept, correct?
Is negative 8 divided by 8 negative 1?
Yeah.
Okay.
No, you're right. I read that as,
No, I'm saying
I don't know why.
negative 8's on top, is it still negative?
Yeah, because one's negative, one's positive.
I'm sorry, I already figured out, so we don't need to go back.
Perfect. All right, so I go to negative 1, and then my slope here is 1 over 4, right? So up 1, 1, 2, 3, 4, down 1, 1, 2, 3, 4.
They'll never, they're parallel.
All right, Gio said, wait a second, they'll never intersect because they're parallel. First of all, how did you know they were parallel?
Same slope.
They have the same slope. Good. I graphed it, and they don't ever touch. Remember I told you at the beginning we were talking. Your solution is where the two lines intersect.
What's our answer?
Do they intersect?
No.
So your answer here would be no solution. Now, algebraically, when you work it out, either elimination or substitution, you know how we do that? What'll happen is when you have like your equations on top of each other, and then you combine down, you'll get something like 0 equals 12. Is that a true statement?
No.
No. If you get to where your variables cancel out and you get a number equals a different number, this would also be no solution. That's what it would look out algebraically. But good, very good. All right, here's a good one, Gio. You look at this, I tell you to solve it. Is it?
Elimination.
Why?
Because of the negative 3x.
Because right away you see that the x's would cancel out. You don't have like one variable set like y equals something. It's not a graph, so very good. I know I don't even have to do anything. My x's will already cancel out, so I can combine here. What's 2 minus 7?
Negative 5.
-5y, good. Equals what's 17 minus 37?
Negative 20.
Negative 20, okay. Divide by -5. And y equals what? Perfect. Now you take 4 and do what? Plug it in. Does this become a little repetitive? That's good. And we're going to do a bunch of these to make sure that we understand what's going on. So I have 3x minus 28 equals negative 33. Add 28 to both sides. 3x equals what's negative 33? My handwriting is not great today. I'm sorry. What's negative 37 and 28?
Negative 11. Wait, negative 9.
Negative 9. Okay, divide both sides by 3. What's negative 9 divided by 3? Say it again. Negative 3. Good. So I found out that y equals negative 3 or y equals 4. Which one is it? Okay. Does it really matter, though, where I put it? Yes, guys, it's an ordered pair. This is a point on the graph. You have to put it in the right spot so that your answer here would be negative 3, comma 4. So your answer here is negative 3, 4. Okay, look at this one. How is this one a little different from what we were doing? There's decimal. Oh, golly. And I'm not going to let you use a calculator. How awful am I?
Wait, I thought you said you were.
Maybe. I don't know. We're not sure. Here's a little trick with decimals, guys.
Make a fraction. No.
We can make them whole numbers. What could I multiply? If I multiplied this whole top by 10, what does it do to the decimal point? Moves it over, and this becomes what?
40.
So I have 4x minus 5y equals 40. Is that easier to look at? Okay, what about the bottom?
Same thing.
Multiply it by 10.
Oh, I could have done that on the SAT.
So this becomes x
I know this is helping right now for this.
equals 3y plus 24. Now, Gio, how does this bode for us right now? What would be the easiest thing to do? Substitution. If you guys just don't like substitution, you could rewrite this as like 4x minus 5y equals 40, and then x minus 3y equals 24. Why did I change positive 3y to negative 3y? Because I moved it to the other side. You could do elimination here if you wanted to. What would you multiply the bottom equation by? Bottom equation to eliminate x's.
Bottom, I multiply it by. I was looking at the negative.
Right? To do negative 4? And then the x's would cancel out. What would you multiply one of the equations by to eliminate y's?
I would have done 5 and 3.
So negative 5 and 3, and that's fine. That's perfectly fine. But you could do it either, that's what I'm showing you. If you did it this way, elimination, what you have to make sure of with elimination is that your x's are on top of the x's, the y's are on top of the y's, and then the numbers are on top of the numbers.
It's so easy to see when you have
It to me, I like it too. I don't like substitution. But some of us do. So we're going to go like this. I'm going to take this. I'm going to just put it right there. Because it says x equals this. So take this and put it in the other equation. So 4 times 3y plus 24 minus 5y equals 40. What do we do with the 4? Distribute it. Good. So 4 times 3 is 12. What's 4 times 24? 96. All right. Minus 5y. What can I do here with the y's? What's 12 minus 5? So 7y plus 96 equals 40. Now what? Subtract 96. So 7y equals, what's 40 minus 96?
Negative 56.
Negative 56. Divide by 7. And y equals what? Negative 8, right? And then we take that, and I'm going to plug it in the x equals. So x equals 3 times negative 8 plus 24. Negative 24 plus 24, x equals 0. Is that an okay answer?
Yes.
Yeah. Is there a point 0 on the x-axis? Yeah, so your answer here would be 0, comma, negative 8. Keone.
How do you get negative 7y?
Yeah, I was gonna.
12.
What'd you do, plus 5, 1?
Oh.
12 minus, see that minus goes with the 5 because it's in front of it. Now, if we did it over here, right, let's just say we multiplied by negative 4. So this become negative 4, positive 12, right? And then negative 96. We end up with 7y equals negative 56, which is exactly what we had right there.
That was a lot less work.
Sometimes happens that way because substitution you have to plug in and then you have to distribute and combine like terms. A lot of times elimination is the quickest. But again, like if it's not set up for elimination, then sometimes it's a harder. All right, let's do some more. Like here, this is set up for substitution. Do you see why? Because it says y equals. You can just take this right here and plug it in there.
I see a very easy way to do elimination.
Okay, how would you rewrite it for elimination?
I bring the 2x over,
Okay,
and then I bring the y over.
so it would be 2x plus y equals 7. And then this would be 4x plus 8y equals 20. You want the x's first, then the y's, then the equals. The thing that's sometimes is tricky with that is you have to make sure of your signs. Once you move from one side to the equal sign to the other, you got to check your signs. Yeah.
Like this one say.
If it tells you to solve using this, then that's what you need to do. But if it just says to solve, then, you know, use whatever way mathematically works. So in this case, it says substitution, just like Alex told us. So we're going to say 4x
Oh wait, actually I said you do substitution.
equals, I know you can. So I'm going to say negative 8. I'm going to substitute in. Instead of that y, I'm going to put negative 2x plus 7, right? And then plus 20. So now we go back to middle school and we just distribute and combine like terms. So negative positive 16x minus 56 plus 20 equals 4x, right? So 4x equals, what's negative 56 and a positive 20?
30, negative 36.
So 16x minus 36. Now what?
Subtract 16.
Let's subtract the 16x, okay? So y'all get negative 12x equals negative 36. Divide by negative 12. And x equals 3. Perfect. How do you figure out what y equals? Plug it back in. Plug it into the one that says y equals. So negative 2 times 3 plus 7. Negative 2 times 3 is negative 6 plus 7 is y equals 1. So your answer is 3, 1. And again, for the 12,000th time that I say this, what could I do with 3, 1 to make sure that I'm right? Plug it in. Good. All right, let's graph some. Are these two lines parallel?
Yeah, wait,
No.
No, they're not parallel because they don't have the same slope. So we know that they probably are going to intersect at some point. My slope here and my y-intercept.
Do you have anything, like, if it was like y equals -1/2, and then y equals 2 on the bottom, would that, like, tell you anything or not?
Perpendicular.
Yeah, but would that, like, mean anything towards your answer?
Means that they would meet at a right angle, but it would still be at a point. But they would intersect. Good question.
But
So
if they're parallel, you could automatically say no solution, right?
correct, but if it tells you to graph it, you need to put the graph. Like if there's a graph there, then put it on the graph. So guys, 1/2. I'm going to go down 1 and over 2 this way. Why did I go down and to the right?
It's negative.
Isn't the whole thing negative?
It gives you the direction.
Oh, it's a negative slope.
It's a negative slope. That means your line should go downward.
Oh.
The direction, guys, it's not telling you that from that point you have to go left because it depends if you go up or down. It's the direction of the line. If you see a negative slope, you should draw yourself a little picture to remind, oh, hey, it's got to go downward like that. Same here. This is your slope and this is your y-intercept. So at -2, and then my slope is 3 over 2. So if I went up, I'd go up 1, 2, 3, and over 2. Which way?
You go down.
But to draw your line, you have to have points above your intercept and below. So yeah, you'll go down 1, 2, 3, and over 2. But which direction? So again, 1, 2, 3, over 2. There's your point. 1, 2, 3, over 2. So your line goes something like this. And again, like Allie said, well, can't you see where they intersect? Yes, you can. But if it tells you to graph it, then graph both lines. So what is that point right there? What's my answer?
I can't read that.
It's 1, 2, 3, 4, -4. 1, 2, 3. Yep, -4, 4. And again, even though you graphed it, you can see where they cross. Algebraically, you can plug in -4 and +4 and see that your answer is what? Correct. Good. All right, let's talk through 12, 13, 14, 15. You guys can do them on your own. We can check later. But how is this set up? Is it set up that says x equals or y equals? No. What would you use here? I think elimination would be good. I think that would be a good thing to use. What about here? Substitution, probably. Again, if you don't want to, set it up for elimination. If it doesn't say so. What should I do here to get all those decimals to go away?
Times 10.
Multiply by 10. What if there was 2 places after the decimal? So 100, like if it was 0.34. You'd multiply by 100 to get it to move over. No.
It was like, multiply that, then it'd be 34.
And then here, what's this best setup for?
Eliminate. Ooh.
Substitution. But if you want to eliminate, you could. All right, let's do this one, solving by graphing. Neither of these are in y equals mx plus b. So let's get them there, please. So I have 5x plus 2y equals 4. And then 4x minus 4y equals 20. All right, so if I want it in y equals mx plus b, I'm going to subtract the 5x. So you have 2y equals negative 5x plus 4, and we're going to divide by 2. 16. God bless. So y equals negative 5 over 2x plus 2. Agreed? So my y-intercept is 2, and my slope is negative 5 over 2. So my y-intercept is 2, 5 over 2. 1, 2, 3, 4, 5 over 2. I went to the right, and then 1, 2, 3, 4, 1, 2, 3, 4, 5, and over 2 to the left, because I want my line to slope downwards. So it's like this. So now I'm going to come over here. We're going to do the same thing. I'm going to subtract 4x. So negative 4y equals negative 4x plus 20. Divide by negative 4. And I get y equals negative divided by negative is a positive. 20 divided by negative 4 is negative 5. So my slope here is 1 over 1. And my intercept is at negative 5. So 1, 2, 3, 4, 5. 1 over 1, 1 over 1, 1 over 1, 1 over 1.
It's x minus 5, right?
Yep.
And then for the other one, did you get y equals negative 5 over 2x plus 2?
Yep. So my solution is at positive 2, 1, 2, 3, negative 3. So it's at 2, negative 3. 17. What's 17 set up well for?
Elimination.
Elimination. What about 18? Substitution.
What's the other one that you taught us?
Graphing. Elimination, substitution, graphing. That's it. Now, in a question like this, guys, what's a couple ways that you could attack a problem like this?
Substitution.
You could use substitution and figure it out, and then figure out which graph it is. You could also take these solution points. If you had no idea what to do, what is that point right there? -1, -1?
Yeah.
Could you take -1, -1 and plug it into these two equations and see if it works? Yeah, you could work backwards, something like that.
Can't you just put it to y equals
You could put it into y equals mx plus b and then graph it if you wanted to. That's fine as well.
See the graph for the one above, because I got.
That's fine as well if you wanted to do something like that. All right, tomorrow, guys, I'm going to finish up. I'm going to talk about the non-linear stuff. We only have class tomorrow for like 25, 30 minutes. So, yeah, it's going to be kind of quick. But tomorrow, you guys we're going to go over the non-linear. It's a little more algebra, but it's not anything you guys can't handle. Promise.